disaster prevention. In this session, will be led by the moderator, Dr. Endrizal Ridwan. But before we proceed, we would like to introduce the profile of our moderator. Dr. Endrizal Ridwan holds a PhD in the field of economics from the Indiana University, Bloomington in the United States. Recently, he serves as the Vice Dean for the Academics Affair at the Faculty of Economics and Business, Universitas Andalas, for the period 2020 until 2024. Ladies and gentlemen, please welcome to the stage Dr. Endrizal Ridwan.
Yes. Okay. Thank you, Tristan. Um, in the name of God, the most merciful, most grateful, and all praise be to Allah, the Lord of the universe. Prayers and peace be upon our Prophet Muhammad sallallahu alaihi wasallam and on his household and companions. Distinguished scholars, honors, ladies and gentlemen, peace, God, mercy, and blessing be upon you all. I would like to say welcome to you, all of you here who can join us. Wait, please. Offline in the conference hall, Andalas University, and welcome to Universitas Andalas Padang. And also I welcome those of you who join us online through Zoom meeting. So it is a great pleasure for me to be with you all today. My name is mentioned, Endrizal, and I will be your moderator for this session. And it's supposed to be 3 keynote speakers in this session. But for one reason or the other, 2 keynote speakers were rescheduled. So we have only one. And we can have plenty of time until the next session. So without further ado, I'll introduce the keynote speaker for this session. He is a professor in hydrology and water resource conservation in the Department of Water Resource Engineering, Faculty of Engineering, Universitas Brawijaya. He holds his PhD in engineering from Miyazaki University and his master and bachelor of engineering from Brawijaya. Please welcome Professor Doni Hari Suseno. Okay, so I have a friend now. I'm not alone. So it's worth to mention among us here, we have Professor Saravan Sabrayan from National Institute of Technology India. Also with us, maybe online or offline, Professor Tung Wang from Institute of Care Life, China. Professor Bambang, nice, over there. Professor Febrin Anas from Andalas University. Professor Abdul Hakam, Associate Professor Indrajit, ASEAN Institute of Technology. Dr. Rustian from National Castle University, United Kingdom. And also Dr. Dodi Ruswandi will be our speakers. Professor Ahmad Safwan from University Technology Malaysia and Suhana Koting from University of Malaysia. So as you know, so our country, especially in West Sumatra, we have like disaster risk area. So recently we experienced Mount Merapi erupted, and its cold lava caused a significant damage to our villages. So a good reconstruction, both a good reconstruction plan, both physically and socially is needed. And today, Professor Doni will present to us urban runoff mitigation system using hybrid G21 system. Yeah. So I almost say G21 because in economic we have G20 and G21 too. So G2I system. So without further ado, I will handle this time for Professor Doni. Pak Doni, time is yours. You can have plenty of time as you like. Okay, go ahead. Thank you.
Any problem with the presentation file? Okay, see. Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillahirrabbilalamin. Muhammad sholli ala Muhammad wa ala ali Muhammad. Rabbi shrah li sadri wa yassir li amri wa hlul 'uqdatam min lisani yafqahu qawli. Okay, good afternoon everyone. It's very nice to meet you all. Yes, everyone in the online or offline presence. It's honor to me to be presenting in front of you. And first, I would like to say thank you to Mr. Chairman for a very nice introduction to me, and also for the committee of the fourth ICDM. I would like to say thank you very much for inviting me as one of the speakers in this conference. I have a lot of benefits to be here, new friends, yeah, new environment, new atmosphere. So thank you very much. Okay, ladies and gentlemen, today I would like to talk about urban runoff mitigation using hybrid G2I system, the hybrid green-gray infrastructure system. Yes, this is not a new system of actually. I think all of you know about this system. In this presentation, I'm going to focus on three main parts. The first part, I would like to explain a general perspective of runoff problem in urban area. And also the second part, I will give a simple implementation, simple case about the hybrid G2I system in managing the urban stormwater, especially in terms of reducing the runoff discharge and extending flood time to peak, which is associated with the flood warning time in the context of early warning system. Yes. And the third one, I would like to make a conclusion. Can I control from here? Okay. Okay. Oh, sorry. Okay. As we know that there are many factors that influence that have a contribution to the occurrence of runoff in urban area. The two major factors are the accelerated of urbanization and also the high increasing of the population growth in the urban area. And the increasing of urbanization rate strongly associated with the land use change problems. And I think everyone here know about this kind of problems. And it's typical problem in developing urban. And normally land use change problem characterized by the increasing the built-up area that directly cause the change of hydrologic response, especially increasing the runoff discharge and shortening the flood time to peak. It means that if the flood time to peak is very short, so it means that we have no sufficient time to make evacuation. So that's why I would like to give you an insight about in the aspect of hydrology, how to get the benefit information about the flood early warning system using the hybrid G2I system. And of course, the impact of global climate change also become the most factors that influence the generation or the occurrence of the runoff problems in the urban area. And normally, we know that climate change gives an impact in the change of rainfall characteristic, the increasing of rainfall intensity, and also the frequency of extreme rainfall event, and also the change in rainfall duration become the most important thing that we must consider in order to analyze the impact of climate change to the hydrological aspect. And both of them expose the risk of urban water issues and trigger the urban water related that consists of urban floods and also overexploitation of groundwater, urban water shortage, the wasting of rainwater resources, and water pollution. Okay, the following slides show the figure that about the pressure of urbanization and climate change on the urban water environment. Said, as I mentioned in the previous slide, that the increasing urbanization and coupled with the climate change give the increasing also in industrialization, population, and also in the built-up area. And the uncontrolled of management of the population growth and also the industrialization, also built-up area, will lead to the occurrence of the problem about the water-related problem in the urban area, and including degradation of urban water environment, which directly lead to the degradation of the urban eco-environment. And as we know that urban water-related problems can be classified into two groups. The first is water quantity problem. Okay, maybe yes, okay. And also the water quality problems, yes. And the water quality problem is normally related with the excessive water, and we call it flood in the common terms. And it can be managed well by having a good management on high flow problems. And the other side, we also have the water sources, or we call it droughts. Yes, this is the problem regarding the water quantity problems, and we can address the problem of drought by having a good management on low flow problems. And concerning the water quality problems, we must sorry. We must try to be the good manager in the management of water quality problems. Okay, this slide shows the flow of thinking in this study. The uncontrolled of land use planning coupled with the climate change has consequence on disrupting the natural hydrological cycle and cause the urban water-related problem that consists of reduced infiltration, diminished groundwater, increased surface runoff, increased water pollution, and degraded water quality. And those are lead to the water quantity and water quality problem, as I mentioned to you in the previous slides. And the question is, how is an effective stormwater runoff management in urban area? In principle, the effective stormwater runoff management must be able to maintain and restore the hydrology of urban site to the pre-developed or more natural condition. It means that if we change the space, or we have planning, spatial planning in our urban area, so we must maintain, we must keep the condition of the hydrologic like a previous condition, like a pre-developed or more become the natural condition. No matter we change, we must try to make the hydrologic condition still like the previous condition. That's the point of the conservation, water conservation. And controlling runoff focus on two main activities, namely controlling runoff volume or discharge, and second is extending flood time to peak. This is the point of the hybrid G2I. If we want to see in the context of flood early warning system. And then the water conservation consists of the conservation in the aspect of quantity. For example, we have a groundwater recharge, and also the aspect of quality. For example, we have a water pollution control. Yes, in the urban area. Okay. The next slide shows the philosophy of the hydrological perspective. Yes, if we focus on the hydrological perspective and flood early warning system, yes, you can we see in this figure. This figure shows the hydrograph of an uncontrolled post-development, which show high runoff discharge and also shortening of the flood warning time. I cannot point in this slide, so it's difficult to make a connection with the audiences. I'm sorry. So the black dotted line show the threshold value of the runoff. We can use, for example, in this study, we use the maximum channel capacity of drainage as a threshold value. So it means that the flood inundation will occur or will take place if the runoff discharge for certain rainfall exceed this threshold value. So it means that we have an inundation or the flood in our area. And if we see on the figure, yes, the red circle point is the time that the flood inundation initiate in our land surface, and the yellow dot line indicate the potential flood warning time available for the early warning system in our area. So I would like to make very simple in the basic of our thinking. So this is not difficult, I think, but I would like to give you an insight to how to see the hydrological management, sorry, how to see the runoff management in the aspect of the flood early warning system. So the uncontrolled post-development tend to shortening time to peak, and it will lead to the insufficient flood warning time. We have and means that we have no sufficient time to make take response for our disaster. For example, we have a sufficient time to evacuate, or take preventive measures. Yes. Thus, we need to propose a method to extend the flood time to peak. It means that we will provide the sufficient time to make a flood early warning time. And this one, yes, the the blue one, yeah, the blue one. Itu warna apa itu? So the hydrograph, if we make a treatment in our system, so as you can see that there is a significant decreasing or reducing or attenuation or flood peak discharge after we make a treatment in our system. And also we can extend the flood time to peak. So we provide sufficient time, sufficient for a flood early warning system, flood warning time. So we still have a chance to manage the evacuate or something like that. That's why the hybrid G2I has a main objective to make the after treatment hydrograph in this cases. What is hybrid? Sorry. This is okay. Uncontrolled post development tend to shorten the time to peak, and as I mentioned to you, it will create the insufficient flood warning time. So we need to extend. I repeat, we need to extend time to peak to provide sufficient flood warning time, so we can have more time to make a response for our disaster. In the case evacuate or something like that. And what is hybrid G2I system? Yes, I think everyone already know about this one. It's an urban stormwater management system that incorporates green and gray infrastructure that works simultaneously to manage stormwater. As you can see in this slide, the left figure, so the various gray infrastructure. We know about the pump system, drainage channel, and also underground tunnel, flood control gate, post culvert, channel, and pipe drain system. And they are known as gray infrastructure. And the left figure, so the various green infrastructure. As you see that the main characteristic is we use vegetation, and also there is a function of storage, function of retention in this infrastructure, and we call it green infrastructure. And the benefit to propose hybrid system, G2I system, is the system has high capability in carrying out the role of rainfall runoff control, and water conservation, both quantity and quality simultaneously. And the system also adaptive to climate change. Yes, there's but in my case, I not give you a case about water quality management, only water quantity management, because actually I also have a case, but I think it's not enough time to prepare the presentation, so I just take the simple case about the water quantity management using hybrid G2I system. And the philosophy, the basic philosophy of the hybrid G2I system is to transform the conventional quick drainage principle to a systematic implementation of infiltration, detention, retention, purification, utilization, and discharge. It means that if we want to apply this system, so actually we can get all of those benefits: infiltration, detention, retention, purification, utilization, and discharge. But it's depend on the case. If we have enough, for example, an area, yeah, so we can area the space for build like a wetland or a detention storage or retention pond. So we can use that kind of infrastructure in our green infrastructure. So the system, yes, is expected to minimize the runoff quantity and quality problem in urban area. And the data used in the model, yeah, we use the spatial model we make. The data is rainfall data and land use data and soil data, and also the digital elevation model data. So by using this data, we can run the model. And the model is this very simple model, one-dimensional model, and the driving equation consists of the computation of runoff spatially in line and channels, and we call it line and channel phase. And we use the momentum and continuity equation shown in the equation 1. And this figure shows the sketch of the processes that we considered in the model. It's very simple. The infiltration and also rainfall, yes. And in summary, we use the concept of flat routing through line and channels. I hope you ever heard about this kind of concept, flat routing through line and channel, but I will not get into detail in this part, so I will skip it, but you can discuss with me later. And we use, the linear scheme of finite difference to solve the equation 1. So this is the final result of the equation. And the second phase is, we call it the phase of green infrastructure or retention system. It depends on what type of green infrastructure you use. Yes. For example, in this slide, we use usual infrastructure like recharge well, sumur resapan Indonesian. Yes, this is normal. This is a common technology that we use even in the Padang, I think. Because I heard from Prof. Bambang about how the government now promote every house is expected to have rainwater harvesting, yes. And the main important thing is, yes, of course, we need another software to make a simulation to assess the combination, the optimizing of the combination between green and gray infrastructure to reduce the flood runoff and to have a flood time to peak. So this is the long journey, long journey. So I have a lot of combination, and I put one combination between the drainage channel and also the recharge well or storage well. So actually I have many combination, but I choose only this combination. And you can use, if you ever heard about the EPA, yes, EPA SWIM, SWMM is Environmental Protection agency storm water management model. Sorry. Yes, stormwater management model is very familiar in our area of the field. We use the SWMM to make like a simulation between one or two construction in the urban area, especially. So in this study, we use the SWMM and for analyzing the for simulating to get the combination, the best combination. Yes. And this is the simple implementation of the hybrid G2I to alleviate the inundation problem at Probolinggo City. Is one of the residency in the East Java province. And the city, the study area is an area prone to flooding during the rainy season, and we have field survey and to get some important information, like we found that the flood inundation occurs due to higher rainfall intensity, and the depth was ranging from 40 to 50 centimeters with the flood inundation duration around 2 until 3 hours. So this is important, and we make some measurement in that time, and we calculate the average of the rainfall, the runoff depth in, and we have 40 and 50 centimeters in average. The measurement, the field measurement in the many points is very useful to calibrate the model that I mentioned to you previously, because after we get the runoff, we need to make assessment. We need to make a verification in the field about the accuracy of the model result. So we change the parameter of the model. We call it calibration process until there is a similarity between the result of the model and the measurement in the field. And the current slide shows the location of the catchment area in the flood-prone area, and it's covered around 24.7 square kilometers. And I will okay. And we use land use in year 2006. And land use 2022, we try to make comparison. Why I choose this two of land use? Because I found that two land use the most significant difference between all the year we have. So in this study, as I mentioned, I have a pre-development and post-development in the previous slide. So I need to establish one year to be a baseline, as a pre-development. So 2006 was established as the baseline for the pre-development condition. It means that I would like to make comparison between the runoff in 2006 and runoff in 2022 using the same rainfall. And I use rainfall in the 2022. So only the difference is in the land use. So I make some analysis, and I assume that TM is still the same, not quite different between both years. And sorry. And from 2006 to 2022, you can see in the table that the most significant increases in the residential area. And we try to verify in the field, and yes, there is the high density residential area in the location study. And the study location, sorry. And the following slides show the map of flow direction of drainage channel. So we must collect this kind of map. It's a very important map because we use this map as an input in the SWMM model. And then after analyzing the evaluation between the channel capacity and the discharge with return period, 5-year return period. And we found that there are 12 channels that suffered with the insufficient capacity. So there is a flood inundation in those channels, and only 12 channels and 13 channels have a sufficient channel capacity in this case. So this is the following hydrograph is the following figures show the hydrograph, yes, analysis of pre-development and post-development. In each channel obtained from the runoff model generated from the each of catchment area of the drainage channel. So we use DEM to delineate the catchment area in each channel, and then we use it as an input in our model. So this is the result between the pre-development and also post-development analyze, hydrograph analyze. And the red color is so the hydrograph of the post-development, while the blue line show the hydrograph in the pre-development. So the black dotted lines show the channel capacity, and we assume that become the threshold value of our system. So each channel is different, the capacity. So the value also different in this hydrograph analysis. And we apply to all channel in this 12 channels, I mean, because this channel has a problem in flood inundation. And we try to make an averagely. So from all channel, 12 channel, so we calculate the average of the increasing, I mean the increasing of discharge, and we found that there are increasing around 62% of peak runoff, or 0.121 meter cubic per second, and also there is a shortening of time to peak. It means that the flood time to peak is getting shorter. This means it become the main problem in the context of flood warning time. So that's why we need to extend the time to peak and attenuate peak discharge, or QP. And we propose the hybrid G2 system. It's a very simple system. We use, like I mentioned to you before, that we use the existing drainage channel coupled with the storage well, the recharge well or storage well. And this is integrated stormwater inundation control for the urban drainage network. So it means that the storage well or recharge well will have run off from the rainfall in the roof of the residential area, and then it will convey by the system of roof to the storage well. And then if the well is full, so there is another pipe as an outlet will connect to the drainage system. Yes, it means that we have a storage in the well, and also we have a detention time in the well. So it means that we have extend in the time, and then we have attenuate in the volume of the runoff that get into the storage well. Okay, and then and we make some field analysis. We take samples. Why? Because we need to check the coefficient of permeability of the soil, permeability coefficient, and unfortunately, this result is not as we want because it's very small, the permeability coefficient of the soil. So the well serve as a storage, not a retention. It's different, yeah. Between retention storage and storage, retention storage and storage well is different. Retention storage focus on the function of retention and have infiltration, more infiltrate water. But retention storage focus on the how to make a storage like yes, in dam, yeah, is it's very small in the infiltrate, but high in the storage, runoff storage. Yes. Okay, this table show the integrated between what I do by using model and also the green infrastructure. In this case, we use the storage well. And yes, I need SWMM to operate, to run the simulation. And this table show the result of the simulation. And this is more technical explanation. We have minimum expected or time to peak or flat time to peak. Oh, okay. I think we need to break for a while. Yeah, allow me to continue my presentation. So in this table, so the result of the model analysis Yes, we use a soil stormwater management model, and we have a minimum expected TP or time to peak value to prevent channel overflow. So I have a basic of thinking that after we get the channel drainage from the previous construction, we calculate the capacity. And from the capacity, we can estimate how many time to peak it should be at least provided by the system. And I calculate this very easy. I use the rational method to obtain the time to peak value to prevent channel overflow. It means that the blue one, the blue one is prohibited to over the black one, the black square. And how to get the blue one? The blue one is the time to peak based on the formulation that we take the condition in current condition. For example, the land use, the current condition, and also the slope on the land. So we have time to peak in the blue rectangular, blue square. Yes. If we have that like a situation where the blue is less than the black, so it means that there is a problem with the flood. Why? Because it's very short. We have no sufficient time to make evacuation, to make a response in the flood occurrence. So we need to extend. At least we need minimum extent is in the black rectangular, black squares. The value is based on the channel capacity. So I need to extend, we need to extend the blue square over than the black one to indicate that we have an extend time to peak, so we still have enough time to prepare everything. This is the simple concept, I think, yes. And, sorry. Okay. And the following figure show the result of the analysis about the flood peak attenuation. And for the 12 drainage channel, so the right figure show the percentage of reducing. So I would like to remind you that we have to focus the main objective is to reduce the runoff peak discharge and also to extend the time to peak. So it means that we can extend the flood warning time. So the result of the model for each channel, yes, they show that the averagely percentage of flood reduction is around 46%, and total flood attenuation or flood reducing is around 1.4 metric cubic per second. This is only the small area, small catchment area. So I take the small catchment area. So the number maybe is not as high as you think about the number of attenuation. So at least I would like to show that from the system that we propose, we can reduce the peak discharge into around 46%. And also the aspect of flood time delay, yes, in 12 channels, yes, we have an average percentage of flood time delay around 56%. And total flood time delay is around 6.94 hours. Sorry, I forget to change to English here. So we extend the time to peak or TP and flood warning time. So we get the second objective about our system. First, we reduce, and secondly, we extend. And if we extend the flood time to peak, it means that we also extend the flood warning time. But this is only the beginning study. We still have more study to complete this analysis, yes. And this table shows the performance of the system in general for the 12 channels. So we focus on the orange and also blue. And if we compare between the column 8 and column 3, is our system sufficient? If the column 8 is more than column 3, it means that the channel that, sorry. Stephen, sorry. Oh, okay. It means that the design discharge, we can control the discharge more than the design discharge. It means that the system is work well in this case. So this is the overall performance of the integrated stormwater inundation controlling system. Of course, we still need to complete. We still need to complete the some aspects. Yes, we still in progressing to complete the model. And I have come to the annual presentation conclusion part. So the integrated stormwater inundation controlling system, or hybrid C2I, perform the best to control stormwater, where the percentage of flood reduction around 46%, and also total flood attenuation around 1.4 metric cube per second. And also we have an extension in the flood time to peak around 66%, and total flood time delay, so magnitude 6.94 hours. And we saw that the system significantly performed best against the frequent descent storm, and the system also can relieve the pressure on the catchment drainage system and also mitigate the local flooding risk. So directly, it will enhance the resilience and adaptation of the catchment to the intense rainfall. And we have a future project about this study that we want to incorporate time varying runoff coefficient. So we make a variation in the runoff coefficient in the urban area. And also we consider about the various temporal pattern of rainfall climatic forecast, as well as the antecedent moisture condition, and also performance spatial and temporal based analysis for runoff analysis to reduce the uncertainty of the flood inundation infrastructure system. So now we still ongoing to research in this part of the future study. Okay, I think that's the end of my presentation. I have pantun ya, pantun Malang ya. I don't know whether orang Padang tahu nggak ini. Kera ngalam mesa-mesem. Ya. Harus ada cakepnya kan ya, cakep gitu loh ya. Kera ngalam mesa, kera itu arek ya. Ya tahu ya. Kera itu kalau dibalikan arek ya. Kera ngalam, ngalam itu Malang ya. Kera ngalam mesa-mesem. Jogo, cakep, oke, sorry. Lagi, kera ngalam mesa-mesem.
Cakep.
Jogo alam, uripe ayam. Sing rusalam, kurang asem gitu. Jadi, kalau saya boleh terjemahkan, Jogo alam itu menjaga alam. Menjaga alam, uripe ayam, hidupnya itu tenang gitu loh. Hidupnya enak gitu loh. Kalau sing rusak alam, yang rusak alam ya kurang asem gitu loh. Jadi kita agak kesel juga lihat orang-orang yang nggak bisa friendly dengan alam ya. Demikian, terima kasih perhatiannya, saya ucapkan Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Pak Doni. It's quite interesting. There's so many figures over there. Probably not all of our participants from engineering department. Yeah, some from social sciences. But I think the idea is quite simple, right? So you build a well, and then the water comes to the well first, and then move. So just to delay that one.
Calculate the run of this using the spatial. So that's, I think, the complicated part.
So it is quite useful for Padang City as well. Because in Padang here, if we have a heavy rain about 5 hours, then flooding everywhere. But then 3 hours later, it's dry. So your technology could be implemented in our city, huh? Maybe next project. Okay, probably some questions, comment from our audience. And I see our online audience has not yet have a comment. Anyone? Yeah, one. Okay, go. Please mention your name and your
Thank
organization.
you. Assalamualaikum, salam sejahtera, salam Pancasila. My name is Didi Sunardi from Pancasila University, Jakarta. I have a question, how about to protect water into disaster? Because into disaster strategy in 24 in Aceh, is water is to not or to consumption to drink. Thank you. About machine for to clean water.
You mean the technology
Yes.
to clean the water? Oh, okay. Yes, actually we have yeah, direct.
Okay,
yeah.
you can answer directly. We have plenty of time.
Yes, actually we have many technologies that we can adapt in the case of water pollution. Yes, but it's depend on the parameter of the water that that pollute. For example, if we have turbid water, yes, air keruh ya, air keruh, turbid water. So the technology is different. If we have a problem like high of BOD, biochemical oxygen demand, or if, for example, if we have a problem with the increasing the high value of COD, chemical oxygen demand, so it means that the technology is different. It depends of the quality of our water. So if I can I ask you what is the problem of the water in Aceh? Aceh. Apa? Keruh, turbid water, high sediment, or
Is it related to last tsunami? Probably.
Yes, let's tsunami.
Tsunami
Oh.
that you have.
Yes,
problem with-
24 is the water not to drink for human because it's too dirty.
oh,
much
to see.
Yeah.
Salt.
I'm question to how to technology for to water human to drink.
Oh, I think you ever heard about the Japanese technology.
Yes.
Yes, it's very expensive, but that's very good if we have a budget, more budget to buy that kind of technology. Because if I see in the television, I don't know, I forget the television or YouTube. Yes, they have like yes, all tube, and then they put carpet water, and the result is very clear. So
It's
yes,
like
but it's very
to purify water.
yes, but it's very
in order to
expensive.
be drinkable.
Mhm. So, but if we have no budget, enough budget to buy that kind of technology, so maybe we use the traditional technology, conventional method, like yes, we need to build the pre-sedimentation, yes, pre-sedimentation, apa namanya itu, itu apa sih?
Sand. Using sand.
Bak itu apa sih? Apa itu?
Oh.
In teknik aja, I forget, sorry. So kita harus membangun kayak bak prasedimentasi ya. So we have to be patient. The first ada bak pertama, and the second one, and the third one, and the storage, yes. But that's very conventional, I think, but very cheap. And if we have a good maintenance and operation, we can get the optimal result also. Yes. But you have once again, if you have enough budget to buy the technology, for example, Japanese technology, I think that's good, yeah. But it's very expensive, I think. Yes. Ada yang kurang pertanyaan jawaban saya? Yes. I'm sorry. Thank you very much. Yes. Yeah.
Okay, thank you. Any other comments, questions? Online questions? Not yet. So, Adi Padoni, do we need to have like large area for your system, like for gray, so the gray one and the green one, right? So that's two, right? Because in here in say in Padang, we don't have enough land, you know, and it's belong to communal lands. And if you take the land, it's very difficult. Now, if you need large area to be like government owned, and that is difficult. So
That's why I mentioned in one of my slides, yes. But I didn't write, but I mentioned in the explanation when I explain that slide that we must choose the green infrastructure that we want to apply in our area. For example, if you have a limitation in the land space, so we cannot apply the like a retention pond or retention pond because they need larger area. That's why I put as my disadvantage system because we need to provide the large area. That it means that we must have a more budget, yeah, if we want to implement the system. That's why this become the constraint, the most constraint. This is the manuscript when I deliver a speech for my guru besar, my professor. Yes. So this is the disadvantage or the constraint of my system. Our system is one of them is you explained previously. We need a more space to implement this hybrid G2I. So we choose only the system that need small storage like recharge well or storage well. But yes, we have a lot of the system, but small system.
Yeah. Because we have Ibu from Pancasila. She's from law faculty, so that you need to have that how the land ownership related with this, you know.
I see. Yes,
Yeah.
yes. I see. Yes. Thank you.
Okay. Mr. Saravan, do you have any comments? No? Oh, yes. Okay, go ahead. Yeah. Microphone, please.
This is a heavy question, I think. This hard question.
I have a small doubt related with that model. How you are incorporating the wells in the swarm model?
Velocity in the swarm.
Wells. Number of wells you shown in that slide.
Yes.
My question is how you are incorporating the stormwater well in the swarm model?
No, swarm water.
SWMM model.
How does swarm water
Well,
build into the whale?
that retention pond or stormwater well, no? How you are incorporate in your model so that it will predict the time lag or detention period.
Yes, if you see the system, I think,
Yes.
I repeat, the simple system, if this is actually a residential base. So we built in the 60 or 70 residentials, yes, yeah, the household.
Yeah.
And the system only receive the runoff from the rooftop. And then we have in our system, we have like talang itu apa ya? We have
rainwater
yes,
storm collection pipe.
yes, collecting from the roof, and then directly we connect it. We connect to the this well.
Water. Yeah, well.
Well, And of course, before we connected, we have a small the rectangular basin for the controlling the sediment. So it means that before the water enter to the
Filtration gallery.
well, yes, it's already clear because we have a filter before enter to the system. Did you get my explanation?
Oh no, my question is, this will, how you will give us a input in that SWMM model?
You connect it to the model. So in the modeling
Yes.
system.
Yes, I need the. As I mentioned to you, I need the software. Yes, the external software. Yes, actually a lot of software like a mic flat and also the SWMM like I use in this study. So in its algorithm, we can make a simultaneous analysis between the runoff from the area, the land spatial, and then the technology of a green infrastructure that we use in our area. So there is many options. The recharge well and then the detention pond, and then we can use simultaneously. Not only one, but you can use 2 or 3 together with the analysis. But in order to get the runoff spatial, I do in the other model. After I get the result, I will integrate to the SWMM to make a simulation. Simulation to know the combination, the effective combination between the green infrastructure and also the gray infrastructure. That's why we can get the optimized combination between green and gray through the software. That software, yes.
Thank you, Professor.
So your question is a big question.
It's very hard question.
Any more questions? Comments?
Okay, sir.
If not, then I don't want to conclude because every words Donnie says is a conclusion. Probably you want to say a closing statement, to the audience and
yes, thank you for being here. Thank you for patient to follow my presentation. I'm sorry if my topics is not compatible with your topic, but I try to connect with the disaster. So I choose to connect with the flood warning time in this my presentation. So if someone interested with this topic, so please do not hesitate to contact me. We can discuss the detail about this subject. I think it's very useful also in the Padang. I think, yeah. Okay. If someone here want to know detail, so you can contact me for detailed discussion about the system. So thank you very much for your attention. Thank you very much. Okay, saya kembalikan ke Pak.
Okay, thank you, Prof. Donnie. Actually, it's very useful for us. As I said, Padang City need this technology, and we might add on your model for some different elevation, because we are in a hilly area and we don't have enough space, so we can modify your model how. Right, there may be some new or modified technology they can provide us. With that, I also apologize if I have make a mini mistake, and then to Pak Doni, we give a big applause. Thank you very much. Billahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. And I give it to Tristan. Go ahead. Yes, sir.
For Dr. Enrizal and Professor Doni, please remain on the stage. Thank you to the wonderful speakers and moderator showcasing us the amazing material. Next is the plaque and certificate handover. The plate and certificate handover will be handed down by the head of Disaster Study Center, Universitas Andalas, Professor Fauzan. Ladies and gentlemen, those are the plenary session 2 that has already delivered by the amazing keynote speaker. Through this discussion, we hope that all delegates obtain valuable insights into the critical aspects of disaster prevention, preparedness, response, and recovery. After this break, all delegates will be expected to go to the parallel room as we start the parallel session in 15 minutes. To all presenters who will be presenting their papers today, please ensure and note that you are in the order listed on the scheduled parallel session 1. These sessions will be led by the moderators for each room or topic, and it will be started with the presentation from the invited speakers and continue to the presenters. To all participants and presenters who are not presenting their paper today, please enter the room that you might be interested in as the topic shown on the schedule. Thank you.